Well, I'll start off today, so I'll just introduce myself. I'm Thomas Henson. I'm work for Dell Technologies, and I'm the Unstructured Data Solutions Business Development Manager for AI and Analytics. And so what that means is that I get an opportunity to talk with customers, and our partner doing really cool things in artificial intelligence and analytics. So span a wide range of different technologies and different paths for where they're going. So all the way from a customer who's just starting out, maybe has something in POC, to larger that have things in production or looking to scale. So today it's about something that I'm pretty excited about, which is voice. So enabling the next generation of voice technology. So in this conference, and we're talking about big data, we're talking about artificial intelligence. In this virtual environment, we're seeing that artificial intelligence is everywhere, right? That's why I'm today to learn more about it. It's in everything we touch. So not just that we're driving, but how we order our groceries, how we order different things online, all the way from your pizzas. I have small kids, and I love the ability to order pizzas and never have to talk to anybody, and do it while I'm on the trampoline out there with the kids, and as they're going crazy, it just helps my life, right? So there's so many different impacts that are really driving it, and artificial intelligence is behind all of that, right? And so today I wanted to talk a little bit around voice technology and dig into some of it. Like I said, I've got some kids. Voice has really impacted the way that the next generation, so I have a 2-year-old and an 8-year-old, the way that I see that they interact with the world, just like mobile phones change, the generations in the early 2000s and into the 2010s, I think voice is doing the same thing. I used to tell a story of when my son was only 18 months and he couldn't even talk. I would see him take a remote control. He would do this at the TV. He was trying to, if you have small kids or baby bum, he was trying to watch that on TV. And what he was trying to do, was he had saw his older sister talk into the remote control that she wanted to. And so he was trying to mimic that because none of us were the channel for him. Fast forward to today, whenever we're in the car, listening to radio, we'll put it on like Kids Bop or something like that, which is some of today's hits. And my son understands that because we have an Alexa at home, and he's able to say, hey, here's his sister say that, play Kids Bop in the car. But when he gets tired of a song, he just did it the other day, we were driving, and he's like, Alexa, which doesn't work in our, and he wanted us to put it in Baby Shark. If you've ever heard the Baby Shark song, it's Baby Shark, doo-doo-doo, anyway. But if you think about how his generation and how he's already interacting with artificial, we can see that, it's in the consumer and as he progresses through school and, into the enterprise, you'll see that he'll be looking for those types of technologies. Just like us are starting to see them emerge as well. One of the use cases that I've been looking at very closely is, natural processing and how that is actually impacting call centers. So it's been to see where, as we've gone to a more remote workforce and, more folks are working remote, the need for customer support. So even internally, if you talk to in your customer support organization in your organization, you'll see that customer support, whether it comes from troubleshooting into working, figuring out how to get your or your laptop to work. And so they've been inundating a lot of requests that maybe they didn't have before when there weren't as much remotely. And so this is one area where we're starting to see natural language and voice technology to be able to help, right? So being able to augment and triage some of those early calls. Now, we still got a lot of work to go with some of those. You may see some of those chatbots or voice-activated chatbots, but that's one area. The biggest thing for the remote work and just even the customer support is this is pushing us to, one, catalog that data so that to offer voice technology within customer support, within smarter, what we call chatbots, right? So this stat was before there was such a push for remote work. I thought this was very interesting, put out by our partners at Gartner. It says by 2023, 25% of all workers will use voice technology to some aspect. Now, I want to try this, so we'll do a quick poll real quick. If you just want to put it in the chat here, does anybody know what that percentage number was last week? So go for the chat, and we'll see if we can get some numbers for it. Just a second. And so as you're kind of putting that in the chat, you start to think about some of the things and some of the areas of your business be enhanced by chat, right? Whether it be search or whether it be, even an education perspective. Okay, not getting any numbers in, but I'll go ahead and give a spoiler alert and tell you that it was 3%. So that number was 3%. So it's a huge jump. Just which I think will be accelerated even more. Maybe it's time to update these numbers. So just another interesting tidbit for where we're going with voice. So before we jump in, I did want to do a little bit of a history around machine, right? So we're, everything within technology and IT, we're definitely built on the shoulders of previous generations that have done a lot of research and work and implementation of technology. And so first I'll start with Alan Turing. So Alan Turing, considered to be the father of science, published a paper on what is now termed the Turing test. And his proposition was he wanted to be able to answer the question of could machines think? And so he wanted to evaluate whether a machine could interact without that human knowing, right? And so this goes all the way back to 1950, and this is what really kind of, sparked artificial intelligence and really human to machine communication. For 16 years, ELIZA, that was out of the MIT laboratory, it actually could communicate from machines, but it was very rudimentary, right? So a very basic communication. Think of this as early chatbots, right? So no voice in this. Then all the way to 2010, now we're seeing the emergence of voice assistants like Siri and Alexa. In the stories where I was talking about how my son wants to change the channel, we're in the car and he wants to listen to Baby Shark all the time. So I did want to do another quick poll. So if you want to put this in the chat here, to this day, software engineers, computer scientists, data scientists, using the Turing test to evaluate, whether these are thinking machines. What do you think? Does anybody have an idea, an opinion on whether we passed that Turing test? Put it in chat here, share it with some of the other folks. We'll look at that as we presentation. So at voice technology, it's just like artificial intelligence and analytics, right? What we're looking for is how do we extract value from that data, right? So if we're using it from a customer support perspective, how do we use that data from me calling in to say, hey, my VPN's just not working? Are there some basic questions that you can get data to be at and build a model that can help answer that question and make out if it's a machine on the other end of using that? So what we do here is we're saying, hey, the data is the most valuable part of it. And me being part of the infrastructure data solutions team, this is an area of my focus, right? I start just looking at training models, or as organizations are just starting out, how do we collect the right data set, train our models to answer those specific questions, and take that data and add it back into our traditional assets, right? So how to increase the value of human capital, intellectual property, operations, and in the infrastructure as well. So now I want to jump in and talk a little bit about AI architecture design. I know my Hamid Dajam did a session yesterday talking about some of these different patterns, and I want to take a twist on it and talk about it from a voice technology and give some insights on how that would work. Let's level set first thing. Let's talk about, if AI is extracting the value from the data, we do definitely need to understand what we're talking about from a data perspective, right? So if we're talking about the structured data and more intelligence, that's where we're measuring and we're doing our processing with CLA, and we generally measure it in, gigabytes to terabytes. As we move back, I spent some time going through Hadoop in the early days, and this is where we really started seeing the emergence of and learning in distributed environments, right? So we started really pushing the boundary into the hundreds of terabytes to even the petabyte range. Some of those use cases, we were predicting outcomes, values, and then detecting the outliers, anomaly detection, and then recommendations. And now, that data was mostly semi-structured, but as we go into technology and we start deep learning, we really start to take advantage of what we call fully unstructured data, right? Rich media types. So if we're talking about voice technology, it can come in the form of text, but it can also come from, holding on to call recordings, right? Stripping out the voice from video data. Image detection as well, too. So, as we look at deep learning, we really start to push the limits on, that petabyte to exabyte range. And then the processing there just need more speed to be. We'll start to push the CPUs and then into the GPUs as well to be able to get that data. That puts some challenges on your and that's why building that architecture and having a framework and also have that speed is really important to organizations and people that are just starting out their AI journey. So how do you get started? Your first voice technology project, it's not magical as far as a project. It still follows, hey, we have a business problem, we need to get to the solution, right? So you start with the end in mind and look for, okay, what is the solution that we're signed for, and then we can map back and see what those data elements are. And so this is a way that customers continue to start out, whether they're starting out small or whether they have a large team of data scientists trying to build it out. And so from my perspective, where I see a lot of customers have challenges is in that last gap, right? So you're starting with your business problems. Say you want to start, you have a new product and you want to be able to take some data in and maybe have some kind of voice assistant that can help triage 1 to 2 different problems early for that customer calls in. They're able to talk to a chatbot to be able to talk. So you've got the business problem, you've hit elements, and typically you'll start off maybe with a POC or prototype, right? And as you start to do that, what happens when you want to prototype into your production environment? That's what we call the lab. Because if we're not starting right with the basic principles, there can be challenges or even delays from your POC and your prototype into production as well. So I said I'm part of the Unstructured Data Solutions team at Dell Technologies. These are primarily what we call PowerScale and ECS products, and these help with the architecture when we start talking about that. How do we be small with our data and be able to scale out to multi-petabytes as well, and also making sure we're not sacrificing performance as we do artificial intelligence. The AI bottleneck as you start to scale, right? Because being able to support 10 terabytes all the way to 2 petabytes, 3 petabytes to build those models. You want to make sure that, hey, you don't have, it takes a month to build and you find out that you only got 80% accuracy and then you have to run it and, every 30 days you're not able to cycle through it, right? So speed, helps that clock time. So, can you reduce clock time, but then also give you a return on investment. So as you take on more, I'm not fearful in the fact that, hey, it's going to cost so much more to be able to, we have to build a new system because we need to add an extra 500 or 2 data. That gives you the ability. And then also that helps you improve your data science productivity, right? So ensuring that you're working through and you're able to quickly train your models, find out where they are, and then go through your retraining. Also is going to give you higher accuracy in those models because you can bring more data to the table. So from an AI architecture, we have these blocks to go from POC to production, but it's really at the end of the day, it's okay, you have your compute, you have your storage layer, and then you have a decision on how do you want to consume that data. Is it an application that you're going to have, or is it in the cloud? And from a Dell EMC and an organization, we have PowerScale that can actually go between both. So either native or even a multi-cloud, so you can take advantage of different applications, whether it be in AWS or Azure or Google Cloud, and be able to know that you have data that you can move seamlessly on-prem into your cloud, and then also have the protection that. And then from a compute perspective, we make sure that we work with our partner and Intel to do all of our benchmarking and our testing alongside with them to say, hey, when we look for this solution scale, what are the performance numbers that we're looking to, and what are the use cases, right? So how can we show at 50 or some of the other benchmarks how quickly you can get to your answer and be able to run your data models. So as customers look to start out, so this is one of my favorite offerings that we have. It's called the Order Bundle, and really what this is best of breed technology from a Dell technology with the Dell Precision Data Science Workstation and PowerScale and switching in between. So for small laboratories that are just starting out, great. So this gives you the ability for your data scientists to have their own GPU, still take advantage of PowerScale on the back end to understand and have that shared data system, right? So as you're training those models, the great this is that it helps you with that last mile. So as you're to build and add more data elements, you can continue to stack on the back end. And it also works on the front end too. So as you more data scientists, you can add more precision data workstations and start to do some of the data center V100 or 81 to be able to scale that performance layer. As I was talking about, your data always stays in place. So this is the great thing when we talk about small laboratories that move into production very quickly, because you've started with that building block around making sure that you're architecting for on the back end. This gives you the ability to be able to add to it. So as you start off with maybe 10 terabytes, you can quickly add without having to do a data migration to launch into production to add 500 terabytes all in the back end. And then it also works as well too that we're starting to see that we want to scale and our data sets need more. You can switch to the C4140s or with the V1, be able to add those GPUs to the front for the processing. The great for folks who are watching this, if you're a data scientist or a data, this gives you the ability to focus on the problem in your use case about the architecture. Because a lot of times what we see happening is a data scientist or a data engineer will look to rework their model. A lot of times they're not looking at what the standard architecture is, and the constant refactoring goes back into their code. So they're looking for inefficiencies in their code where, standardized benchmark, having a white paper that'll kind of walk you through and say, this version here, you can expect to process this many images depending on, what you're running, whether it's ResNet or some of the other benchmarks as well. It just gives you that peace of mind to know, hey, okay, I've optimized architecture, now go and solve the data science problem. I did want to bring up too, as we start to look at, maybe started with a POC, or maybe you have, a POC and you look production or looking to scale. We also have what we call the AI ready solutions architectures. And so our ready solutions, if you look, it's a Dell EMC with embedded with GPU, with the networking, and even has the workstation so that you have your Jupyter notebooks for different, whether you use TensorFlow or MXNet or PyTorch, the ability to have that all siloed in your one in your data science, in your AI ready solution, and train your models and do deep learning. So this is really to get you off the ground to be able to scale. And then as you add more data, you're able to scale just as well. And then we also have the reference with Nvidia, so the DGX1 and DGX2, and we're doing the testing for the DGX A100s. And these are verified solution with Nvidia to give you the ability to scale. So just like with the ready solution we were talking about, your network compute and your Isilon F800 on the back end to be able to scale into that multi-petabyte range for those data models. And so if you're a POC right now, this is one option here to get you kind of off the ground and be able to put these, know that they're validated and supported from a NVIDIA perspective. I will say we had a new offering this year, artificial intelligence from the EDS perspective called PowerScale family. And so with the addition of our all-flash F800, and we've added 2 more models to be able to start. And we talked about those when we were talking about that ready solution is the F600. And so these give you the ability to use all-flash or DME to be able to power and build your models. still interconnectivity with the hybrid, so still can add the hybrid or archive just depending on your data policy, and then all those are with our PowerScale in the cloud. So whether it be multi-cloud for Azure, AWS, or Google Cloud, or natively our PowerScale 1FS with Google Cloud. And once again, all of these with 1.0 are interchangeable, so you still get your replication, still get the add and scale those as your models and flows permit. Now, another challenge when we start to talk about artificial intelligence and data is how do we make sure that we get insights into our AI or in our data, right? So as more and more data comes on, how do you answer that? And maybe you have different systems or third-party applications that are outside of the PowerScale family that you're looking to get insight. And this is where data IQ is really the data science visibility to find a data pipeline. So not only do you have a comprehensive look at where your data elements are and what they composed of, you can actually write APIs. So a lot of customers have custom applications that they use to move data around or to tag and look at different models. All can happen here with data IQ. You actually add to and use the APIs to integrate your application. So you can pull the data and pull the information from data IQ for those APIs for your specific code that you have. Great thing about this is PowerScale, ECS, even third party in the cloud, insight into your unstructured data, and not only just also act on it, tag that data, track and analyze it within your environment. So think about it. If you're sitting there and you're excited about that, and you go back, think about all the unstructured data you have and what's your process for. What happens when you want to retrain a model? What happens when that product, so the example we were using for voice technology, new product, what happens when there's another feature or you want to retrain that model, right? Have you archived off some of that data? Do you have to do the manual movement? With Data IQ, this helps simplify that and give you the ability to do it, and also give you the ability to evolve it with the APIs. From our approach, it really applies. We call it the data first approach for AI initiatives, but what we're looking for is where does it make sense for that data to be, right? So are we building models on-prem? Are AWS or Azure for some of those, and we can take advantage of multi-cloud. That has you covered from that perspective. And so is Data IQ, right? So you can know what it is, and then if you're consuming PowerScale for 1FS and Google Cloud, actually move and transport that data all natively within Isilon and not have to worry about any migrations on your end. So the future of data science, like we talked about, is right. You look at these almost 500 different applications. Maybe I'm kind of biased, but I would say 40 to 50 are AI and analytics. And so it's really, from a Dell technology, we want to make sure that we can help our customer leverage all these services. And not be tied to one specific cloud, right? And so be able to run and take advantage of services that are in AWS and Azure, all with the same data set as well. And so, definitely, at the end of this session, make sure you reach out to me. I can help you and show you some of them do that. And there's some really interesting solutions here from an artificial intelligence perspective to really help out. And then finally, at the heart of it, like I said, Dell EMC Powerscale is enabling that optimal data pipe AI at scale. Whether we're talking about Data IQ or whether we're talking about your Cloud IQ and using it for your infrastructure insights, it can take the guesswork out of trying to figure out what's going on with your artificial intelligence so that you can focus on building your models and focus on the engineering that goes behind it, right? And then multi-protocol access. So consume any data anywhere, from edge to cloud. 1FS is really the secret sauce to that as well. So finally, if you're here, my thought is, specific use case that you're looking for. If you're trying to take on voice, find one or two use cases that you can find that you can put quantify, and start to build those. If you're involved in a POC, definitely reach out. Help us involved, help us, have us help and evaluate and do a for your server configurations, and then also help us let us help you engage you in that POC AI solution so that you know with the artificial intelligence architecture that's really on the system. So if you have any questions, feel free to reach out. In this slide deck here, there's a ton of useful links kind of detailing, deep diving on some of the configurations for all the solutions that I've.
Got it. Thanks so much, Thomas. While we've got a minute, I think, I'm not sure if we've got time for questions, but did you want to say a word about the poll and perhaps, where you're going with voice? What can we expect?
Yeah, no, I'm excited to see it, and even the Dell technologies, as we start to see more push in the call centers and support centers. I'm eager this, and I will not. I know I put it in the poll, but I will not comment on whether we've passed the Turing test or not. I'll leave it to be debated somewhere else. But I do appreciate everybody putting their input in. So what did you want to jump in on that one and say if we passed the Turing test or not? Or?
Well, I think that's great. Thank you so much, Thomas. And I'll hand it over to our next speaker. But have a great rest of your day.